example 4, we have x plus 3 to the power of 4. First thing I want us to point out is the exponent of this binomial is a 4. So when I go through and I am applying these things that are true about expanding binomials, I like to do it kind of in a 3-tiered process, and I create 3 rows that I'm then going to multiply straight down. That's one way to organize your work. I'll show you another way to organize your work as well if you would rather do it a little bit different. So the first thing I'm going to do is I'm going to identify the 4th row of Pascal's triangle. And I know I'm going to use the 4th row of Pascal's triangle because my exponent here is a 4. So that says I'm going to use the 4th row of Pascal's triangle. The 4th row of Pascal's triangle, if you refer back to that table, is 1, 4, 6, 4, 1. So what I'm going to do is I'm going to write out a 1, 4, 6, 4, and 1, and I'm going to leave some space here. Because really what I'm doing is I'm going to create these columns that's going to eventually represent each term of my final answer. Now, if we refer back to part 3 from that table of true statements about binomial expansions, part 3 said your A term, the first one is going to be the power of n, and then it's going to descend by 1. So my first term is an x. So I'm going to start with x to the original exponent of 4, and then it's going to descend by 1. X cubed, x squared, x to the 1, and then x to the power of 0. After that, I'm going to take my last term, which in this case is a positive 3, and it's important to take whatever sign is in front of that number, and I'm going to raise it to the power of 0, and then I'm going to increase by 1. So items 3 and 4 on that slide just before this one are saying that you take your first term, raise it to the original exponent, in this case 4, and it descends by 1. Take your second term, raise it to a power of 0, and it increases by 1. So notice that they're going in opposite directions. Okay, that piece is important. Now let's do a little bit of simplifying here. 3 to the power of 0 is just 1. 3 to the power of 1 is 3. 3 squared is 9. 3 cubed is 27. And 3 to the 4th is 81. The other thing we can simplify, and you might not have realized this, is x to the 0 is 1. Because anything to the power of 0 is 1. So this variable x to the power of 0, we can actually simplify that to be 1. The process we're going to go through next is we're going to multiply these columns straight down. So what we're going to do next is we're going to take all of these columns and we're going to multiply straight down to get our answer. So I'm going to take 1 times x to the 4th times 1, which is x to the 4th. Then I'm going to take 4 times x cubed times 3, which is a positive 12x cubed. Because remember, I'm taking this 3. I don't need the 3 to the power of 1 anymore. I just need the simplified version of it. Then I'm going to take 6 times x squared times 9, which is 54x squared, and it's positive, so I'm going to say plus. Then I'm going to take 4 times x to the power of 1 times 27. 4 times 27 is 108, and then x to the power of 1, or just x. Then I'm going to take 1 times 81, which is 81. And that's our answer. Now, I arrange mine using rows, but if you don't like doing that and you want to write it as one great big line with all the pieces added together, you can do that as well. So let's go through one last example of this, and then we will be all done with multiplying polynomials. Try this one on your own first, then press play to see the answer. So we have x minus 4 to the power of 6. Because we have an exponent of 6 here, that means we need to first start by writing down the 6th row of Pascal's triangle. The 6th row of Pascal's triangle is 1, 6, 15, 20, 15, whoops, I'm running out of room, 6, and 1. I tend to write things pretty spaced out just so I have enough room. Now I'm going to take that first term from my binomial, which is an x, and I'm going to start off by raising that x to the original exponent of 6, and then it's going to decrease by 1 for each term, ending with something to the power of 0, and as a reminder, that just simplifies to 1. Now I'm going to take my second term, which is -4. Remember, you have to take that sign with it. And don't forget your parentheses. So we end up with -4 to the power of 0, -4 to the power of 1, -4 squared, -4 cubed, -4 to the power of 4, -4 to the power of 5, and then -4 to the power of 6. Now we're going to work on simplifying this. -4 to the power of 0 is 1. -4 to the power of 1 is -4. -4 squared is a positive 16. -4 to the power of -3 is a -64. -4 to the power of -4 is a positive 256. -4 to the 5th is a -1024. And -4 to the 6th is a positive 4096. So now that we've gone through this process of simplifying each of these pieces, our last and final step is to multiply straight down. When we're multiplying, we're just looking at multiplying these coefficient pieces, if you will, together. So I'm going to take 1 times 1, which is 1, and then multiplying that by the variable. So I get 1 x to the 6th or x to the 6th. Then I'm going to take 6 times the x to the 5th times the -4. Really, I'm just multiplying the 6 and the -4 together to get -24 x to the 5th. Then I take 15 times x to the 4th times the positive 16, which gives me a positive 240 x to the 4th. Multiplying the second column, 20 and -64, gives me a product of -1280, and then the variable x cubed tags along the end. Multiplying the coefficients of 15 and positive 256 gives me positive 3840 x squared. Then I take the product of 6 and -1024 to give me -6144, should be x. And then last but not least, we're doing 1 times the positive 4096. That's the easiest one. We get positive 4096. And that really long thing is our answer when we multiply those binomials together 6 times. So, though this process can seem a little bit intense, it would be much more intense if we were taking x minus 4 times itself 6 times, and it would be really easy to make small mistakes. This expedites the process, and it makes us less likely to make those small mistakes because we're dealing with smaller pieces at a time versus everything at once. Hopefully you found this helpful. If you do have questions though, please reach out to myself or Mr. Brasser, and you can now move on to the 3.2 homework assignment. Thank you so much.